Hello everyone, welcome to WSAP 2023. The title of our paper is Self-Supervised Low-Dose Computed Tomography Image Denoising Using Invertible Network Exploiting Interslice Congruence. I am Sutanu from the Indian Institute of Technology Kharagpur. This is a joint work done with Professor Prabir Kumar Biswas. Nowadays, deep neural network based methods have emerged as one of the most promising methods for denoising or artifact removal of low-dose CT images. However, this method requires paired, noisy and clean images, which are rarely available in medical imaging, which in turn limit the practical implementation of this method. In this study, we have proposed a self-supervised method for low-dose computed tomography image denoising, leveraging the recently proposed concept of invertible neural network. In our paradigm, during the forward mapping of the invertible network, the input image is mapped to the average of its two immediate neighboring slices. We have shown that it is similar to training a network using noise-to-noise paradigm, and during the reverse mapping, the output image is again mapped to the original noisy image. This is the formulation of our invertible layer. The input image is first split into two groups using channel-wise splitting. Then the output feature map N1 and N2 are formed as shown in the slide. And during the reverse mapping, the input is reconstructed back from the N1 and N2 as shown in the slide. Now consider Y1, Y2, Y3 are three adjacent noisy slices and X1, X2, X3 are the corresponding clean slitty slice. So Yi is equal to Xi plus eta I, while eta I is the added noise. Ideally X1 should be equal to X2 plus delta 1, where delta 1 is the offset which compensates small axial distance between two slices. Following some simple steps, we can find half of Y1 plus Y2 is actually equal to X2 plus some eta 2. Now, according to the noise-to-noise minimizing, the distance between Y2 and half of Y1 plus Y3 will be similar to minimizing the distance between X2 and Y2. In our setting, we employ two encoders EX and EY and two decoders DX and DY and a invertible core I. The encoder projects the input and output image to a higher dimensional feature space. The invertible core process this feature during forward and reverse mapping. Finally, the decoder projects the higher dimensional feature to input image space. So the mapping for the forward and reverse mapping is given by the following. Here is a graphical representation of the proposed method. These are the different components used in the method. During forward pass, MAC loss between the input and average of Yi minus 1 and Yi plus 1 is used, and for reverse mapping, MAC loss between the input of the reverse map and the original noise image is used. Here is some ablation we had done. As shown, using the invertible network, an improvement of 0.46 dB can be found. Visual comparison among the output of different trained network. Comparison with different state-of-the-art method. Visual comparison of the different method. Visual comparison using a different dataset. Thank you for listening to our presentation.